I'm Brad Smith, and this is Tools and Weapons.
I was lucky curiosity never escaped me. I think every child is born with curiosity. I think it's in our DNA. It's who we are as a species.
That's Dr. Fei-Fei Li, a pioneering AI scientist, entrepreneur, and a Stanford professor who is leading groundbreaking work on computer vision. On this episode, Dr. Li shares the importance of keeping human values at the center of AI development. We also explore how government-funded academic research, driven by curiosity rather than profit, leads to unexpected but profound discoveries that have long fueled American innovation. Fei-Fei Li, up next on Tools and Weapons. Well, let me first say welcome to what I think is the opportunity to talk with one of the world's greatest computer scientists, AI experts, now an entrepreneur, a person who's connected with technology and its societal impact in the United States, around the world. Dr. Fei-Fei Li from Stanford. Fei-Fei, welcome. Thank you for joining me today.
Thank you, Brad. I'm so excited to join you and just have a great chat.
Well, you have such an extraordinary personal story. You've written a terrific book about it. And there's one word that I would like to talk about with you today. The word is curiosity. The role it has played in your life and your success, I think the role it can play for everyone who's listening and the future of technology. You, I think, have almost always been a curious person. Where did that interest, that spark of curiosity first enter your life?
Well, first of all, Brad, I'm so glad you picked that word. Really, it's the title of my book is The Worlds I See, but the first word in the subtitle is curiosity, because I think that is absolutely the through line of my life as a scientist. And I think it's really, frankly, one of the gift of life. So you asked me, where did it come from? I actually want to say that I was lucky curiosity never escaped me. I think every child is born with curiosity. I think it's in our DNA. It's who we are as a species. Frankly, even as scientists have studied that even primate species and other animal species have curiosity. So this is a huge gift that humanity has for itself. And what is really a gift was that my early years of development or growing up, one way or the other, and a lot of credit to my parents, they protected that. So despite whatever ups and downs of life and the changes of circumstances, I was lucky since I was a little girl that curiosity was protected. It grew. It became a fire that continued to drive my life, right? You mentioned that I'm now an entrepreneur. It's kind of a weird choice in this stage of my life. At least a lot of people would ask me, why are you doing this? And the fundamental answer to that question is curiosity. I'm just so excited to be doing what I'm doing. So, yeah.
I would love for you to share a couple of stories about how this sort of came together for you, because I think they're very relatable and they're very interesting for people. And you tell these stories in your book. But for someone, and we'll get into this, who's been a leader in computer vision and images, pattern matching, and the like. When you were growing up, you accompanied your father, I think, to quite a number of yard sales. Tell us about that.
Yeah, so you're referring to our early immigration days. When I was 15, I joined my dad. My mom and I joined my dad in New Jersey, of all places, Parsippany, New Jersey. And, being an immigrant or immigrant family is really tough. We literally went from a middle-aged, middle class family in China to really, really, really impoverished in New Jersey. And one of the way we survive is just buying items from yard sales and garage sales, that they are cheaper and so on. But I think the scene, and I think I wrote it multiple times in the book in different light. The scenes that you're describing is on the weekends, I would go with my dad to yard sales. But now that we're talking, it sounds like such a boring or not even a great thing to do. But you have to transport yourself to my perspective as this teenager going to these yard sales with her dad, who didn't speak English, but the way he approached this tiny event in life on a weekly basis is so much curiosity. He would approach every little like stand or table of whatever items with that kind of pure childlike, oh my God, look at Feifei, come and look at this cup. It has a owl on it. Or look at this garden tool. I've never thought of, you can design it this way so that it's easy to uproot a plant. He would just see everything with that childlike, beginner's mind, childlike delight. And that was just something that, it didn't occur to me then. But now that I've been a scientist, a career scientist for decades, I realized that delight in seeing things for the first time and keeping that curiosity is the same as what we do as scientists. The first time I open a paper, look at the results someone gives us or heard about an algorithm, you have to have that delight and curiosity.
One of the wonderful lessons, I think, from that experience that I just feel is of universal applicability is that almost every moment in life, even the seemingly most mundane, often creates an opportunity to learn something new. But
Yes.
you have to look, you have to listen, you ask questions, you retain that sense of wonder.
Yes, the sense of wonder, yes.
And it's a wonderful thing, that sense of wonder. And obviously you built on that. You got this scholarship to go to college in New Jersey at Princeton. You were obviously not just curious, you were a hard worker. And one of the stories you also share is how you poured yourself into your classes, your academic work, even your tests. There was the day you took an exam, I think really outside a hospital room where your mother was. Can you tell us a little bit about that and how that fit into your development as a person?
Well, thank you, Brad, for reading the book with so much details, and also, the university I went to, a thing or two about that.
True.
It's our shared alma mater. So, first of all, this book is written as a scientist coming of age and also a scientific discipline, AI coming of age. It's not meant for a sob story. And that is not how I approach any of these story. The story, the thread that you're referring to right now, to me is a love story for immigration, is that millions and millions of American immigrants work so hard with a sense of hope and dream, and I was just one of them. And that it's true that it was difficult years. My mom didn't have good health, and especially because she's a cardio patient, so her heart is very ill. And that thing you talked about was during freshman year in Princeton. I had to take my mom for a quasi-emergency surgery in a hospital, and I had to translate for her because it was a surgery that part of her remains awake and has to respond to the doctor, and I was the only translator, and I was also taking exams, so I got Princeton to allow me to do that literally in scrubs, because I have to be in the
Wow.
area where she was, and take my exam while being there to support her and support the doctors. But overall, it was a tale of two towns, not tale of two cities. One is where I study at Princeton and physics, and I loved every minute of it. It was painful, it was hard, but it was fun. But it was also the story of Persephone, where my family lived, and we had a dry cleaning shop that in Silicon Valley language, I was the CEO of the dry cleaner, and I employed my parents, and it's a weekend business, as most dry cleaning business are, and I was working hard there as well.
Well, what I find interesting is those two towns came together for you. Your journey progressed. It took you from Princeton on the East Coast to Caltech on the West Coast. And I think there was a point where you had a fork in the road. As you were at Caltech, you had the opportunity to decide what to do next. And one path led to McKinsey, obviously great management consulting firm. They offered you a very high salary, and the other was to continue with a quest for science, which certainly at the time would not have appeared to have offered as much money. And you had a conversation with your mother about what you should do. What did your mother tell you?
Yeah, so that was, I think a lot of students would experience that, but my situation probably was exacerbated by the family financial situation. Is you're in the middle of grad school, the second, third year of PhD is the hardest. You're in the PhD blue, and papers get rejected, and you don't know if you're gonna get a good job. Especially at that time, AI as a field was still in the AI winter, so it's unlike today's AI generation. If you're an AI student, you'll have so many jobs waiting for you. At that time, that was not true at all. If you're an AI student, the industry was not quite there yet, and faculty job is so competitive, and I was just so worried. And on top of that, my mom's health continued to deteriorate, and I cannot, dry cleaning is not a career aspiration for me.
I understand. We all appreciate people who do devote their lives and careers to dry cleaning, but I can understand what you're saying.
Yes. So I, it was very easy. Career fair, senior graduate student, one thing led to another. I got offers from McKinsey, right? And that was not a huge surprise. But what was a surprise is the difference between the salary I would have been getting from McKinsey versus what my family has ever experienced in this country. And that was when I was wavering. I was just not sure. But the fact I was wavering also shows I loved my science, and my mom was always the first person there. She's just like, go for what you love. Like, what are you agonizing about? It's for her, it wasn't as agonizing as it was for me. And that is a courage. Again, as a kid, you never appreciate your parents till you become too old.
Yes.
And in hindsight, it's an incredible courage. It's also an unconditional love. It was a gift of love. She was absolutely selflessly thinking about me, not thinking about her, her lack of medical insurance, her, lack of healthcare and all that. She just thinks, go for what you love. And back to curiosity. Curiosity is not just to me, curiosity is not just moments of delight or sense of wonder. Curiosity is a state of being, and that state of being makes me happy. And being a scientist makes me happy because I'm entitled to be curious all the time. And my mom knew that. And that's what she encouraged me to do.
And your curiosity and that passion, that quest for science, took you down a path in the early 2000s when you created something that did not exist. I don't think people understood that it would become as important as it has. But basically, you started to build a great data set of images. You called it ImageNet. Tell us about ImageNet, what it is, how it started, what gave you the inspiration to put it together.
Yeah, thanks, Brad. ImageNet was a project that took us 3 or 4 years, starting 2006, 2007 to build till 2009, 2010. And at the end, it was the largest data set that AI field has ever seen, consisted of 15 million images, hand curated with labels and cleaned up to across 22,000 visual object categories. And these images are internet images from everywhere in the world, each one meticulously curated and organized. And it became a essential training data set for all AI algorithms, especially engendered the deep learning revolution, because neural network algorithms will become the biggest consumer of ImageNet. And I think the significance of ImageNet is not the number of images per se, or the modality that it's a visual image, a visual data set. It's the concept of big data. Because now, fast forward to 2024, 2025, big data is such, nobody even thinks about, questions about it. If you want to do AI, you need 3 things. You need GPUs, you need neural network algorithms, and you need data. Everything we've seen, from AlphaFold to ChatGPT to Gemini to whatever, the Transformer, the latest and greatest AI algorithms, models, products, it's built upon these 3 ingredients. But before ImageNet was developed, big data was not a concept. People were, in fact, working with small data. In fact, data was not appreciated at all. Data was just an afterthought after you build some algorithm and then you try to just, grab something off somewhere and hope that you can train a model. And we observed before we made ImageNet that that's just a wrong way of thinking. Mathematically, these machine learning models need to be able to learn and generalize, and the way to drive that learning and generalization, in addition to the architecture of the algorithm, is actually through data, and diverse data, and large amount of data. So that concept was initiated by ImageNet, and therefore, very luckily for us, ImageNet had a outsized impact to the revolution of deep learning.
And I think one of the reasons you could pursue ImageNet, and certainly something that has been fundamental to your career, has been a commitment to be part of academia, to work in a university, to pursue basic research around, in this case, images and then computer vision. Tell us a little bit about why you're so passionate about academic research for computer science.
Yeah, so Brad, I think my fundamental passion is about the ecosystem. And as a beneficiary of America's innovation ecosystem, I think academia and public sector plays a critical role. And of course, we have seen that, is that when you have a very, very good academia ecosystem, as part of the ecosystem to technical and scientific innovation, you can pursue ideas with curiosity. You can train students who are just with boundless energy and creativity and passion. And then you can work with the rest of the ecosystem to turn that into real technology and products that can be delivered in the hands of people. And that ecosystem is extremely is rare. I mean, America truly has the best in both compared to the rest of the world, as well as in the history of human civilization. And personally, curiosity-based research is best done, in my opinion, in academia by and large. You know, even today, we can talk about today, there are challenges. I still think academia is a fertile playground where researchers and students are allowed to just imagine the unthinkable or imagine something that people will laugh at. That's what happened to ImageNet. But then you do turn around and change the course of the technology and science.
And share, if you could, a little bit more about that phrase, which I think is commonly understood in the world of academia, curiosity-based research. What does that mean, and what is curiosity-based research compared to, say, other types of research?
Right. That's a great question, Brad. I think curiosity-based research fundamentally is linked to the word freedom. Is that when you are a researcher or professor in a university and academic setting, you don't have a manager or a director who tells you, Fei, come here to Princeton or Stanford, and these are the 3 things you should work on. No, you're just given a desk, an office, and an opportunity to apply for funding, and then do whatever you want. Of course, it's not as free as you think. Whatever you want is based on your expertise. I was trained as an AI scientist. I'm not going to do, chemistry. That will be, even if I try to do that, at least at the beginning without a credential, I would not have street cred to get funding.
Mm-hmm.
But because of that freedom, so specifically like ImageNet, right? I was a young assistant professor. At that time, I was just landed in Princeton. I went back to Princeton as a faculty. I had a lab of 2 students. Nobody told me what I need to do. I was exploring. I was passionate about this big data idea. And then I start just do it. In the meantime, of course, I was so excited. I chat with my colleagues, and some of them will say, well, that's kind of a bad idea.
Mm-hmm.
Some of them would even go as far as saying that might be an idea that hurts your career. But even with these pushbacks or debates, nobody said you're not allowed to do it. They would just say, this is my opinion, it's a bad idea, but you're still allowed to do it. I also got rejected by grants. But again, even with that rejection, it's still freedom. You can do it if you can pull it off, but no one says no. Nobody, and also on top of that, no one says you should be doing what. And that allows so much curiosity to flow. And of course, I don't want to rosify it. It also requires resilience and perseverance and courage, because you do hear comments and opinions, and you have to decide for yourself. Do you want to change course or stick it through?
One of the key words that you mentioned is funding. You're given the freedom to pursue your curiosity, but you do need funding. It may be for lab equipment, it may be for computing time, it may be to employ graduate help, postgraduate fellows and the like. In the United States, a lot of that funding comes from the federal government, the National Science Foundation, the National Institutes of Health. What role did the NSF or other federal funding play in the development of your career and the pursuit of your research?
Overall, it's critical, I would say. Of course, you have to take it down and analyze which project got funding. But as you said, for my early years, absolutely the National Science Foundation is the one of the major funding source. Another major funding source was the Navy Research Lab. Funding we call Office of Navy Research, ONR. The Office of Navy Research is especially known in the field of computer science, computer vision, to create these multi-university research initiatives. And they would fund a group of professors from different universities to try to motivate multi-university collaboration and multidisciplinary collaboration. And throughout my career, I have been on so many ONR, we call MURIs, multi-university research initiatives, and that's critical. Also, industry played an increasingly important role. When I started, 20 years ago as a young faculty, my very first industry grant was from Microsoft. Thank you, Microsoft. It's a new faculty fellowship, I remember, because I was really new. But gradually, my lab has received funding from Google, from Microsoft, from Amazon, from international partners like Panasonic and Toyota and NVIDIA. And so that ecosystem of federal funding and as well as industry funding back into academia to grease the wheel of innovation is so critical.
And the other aspect of this ecosystem is, for those of us in industry, it's a little bit like standing on the shoulders of giants. There is so much research that comes out of academia that we build on top of. And I think this has been true since the dawn of serious computer science research. It's been true of many industries in the United States. And the research comes out of the universities in multiple ways. I mean, you publish, we read your papers, we derive insights and bring those into our products. And another critical aspect of just the economic and innovative dynamism of the United States is that people start in a university and then they leave and they start a company, or they remain in a university these days and they still start a company. You are today both an academic and an entrepreneur. Tell us a little bit about this entrepreneurial pursuit that you are now focused on.
Yeah, you're right, Brad. And that's what I love about America's tech innovation ecosystem. It's very porous. Nobody gets to be forced to be put in boxes, and you can even be put into multiple boxes. Maybe we're all Schrodinger's cats. And it's because this tech is, especially AI these days, is so fast moving. People from industry and younger generation and academia, there's so much flow of knowledge and capabilities. It's almost impossible to be so boxed in. So as my and another thing about academia is you're allowed for leaves and sabbaticals, and of course you are also allowed to stay leave academia. So just a year ago, when my new round of sabbatical or leave is coming up, I was feeling pretty restless because I realized my own field of computer vision is going through a new revolution. The technology such as transformers, diffusion models, neural rendering, and all this is recombining deep learning, computer graphics, and computer vision into a new generation of possibility, which I call spatial intelligence. It's really the fundamental technology to understand and generate 3D worlds and allow the kind of interactivity that we have never imagined before. And as I was getting so excited by this idea of spatial intelligence, I was recognizing that it was a particular idea that academia doesn't have enough resource for, because it requires data, it requires computing, and it requires also a larger group of talent focusing on solving that. And so together with my former students and just young colleagues in the field who are so at the forefront of the field, we started chatting about this idea. We got more and more excited. We decided, you know what? Let's be entrepreneurial. Let's be curious. Let's be bold. And we want to solve the problem of spatial intelligence. We want to create world models that would allow a new experience, a new family of products that allow users to experience the ability to create 3D worlds, to interact in it, to use it for their productivity and creativity. So that's the path we're on for World Labs.
Well, as we come to a close, I think it's an interesting moment in time to look at the issues of our day and reflect on, I think, the various lessons that emerge from the conversation we've had. I think 2025 is a year when many people will ask, quite rightly so, where are our tax dollars going? How is the federal government spending money? What are programs worth funding and what are programs that are not? When the conversation turns to basic research, the role of universities, the federal support for universities, the ability of universities to stay financially healthy, as someone who came to this country and has pursued this career, what advice would you have for lawmakers in Washington as they think about this aspect of federal policy?
Yeah, so Brad, for the past 5 years, I maybe at the beginning reluctantly, but now I'm actually proactively have been advocating for resourcing our public sector research and technology, because not only I personally benefited from it, but as we discussed, I see this as a critical component of a unique ecosystem of innovation that no other country or no other time in history has ever, had. And I want to contribute to protect and to grow this ecosystem. So even as an entrepreneur who are on the side of the industry research side rather than the academic research side, I gain even more understanding of how important it is to resource our public sector and academia, because that's where so many innovative ideas come from. That's where students are trained, and that's where the academia can also play a role to, arbitrate and convene challenging debates and just really get people to have rigorous discussions of very, very critical and challenging topics. So I would say to any lawmaker and policymaker that treat this ecosystem, treat the public sector and academia's role in this ecosystem as a strategic asset to invest. And that asset is both people asset as well as knowledge asset, public good asset, and we need to invest in this. And that's, in my opinion, the only way to keep this ecosystem healthy.
And as you can probably tell, it's something with which I emphatically agree. It's so interesting because I think as I travel the world and over the years have met with leaders in other countries, I've often encountered government officials who've said, we have studied the United States because we wanted to understand what was making the U.S. so successful when it came to economic competitiveness, research, innovation, the real dynamism that I think is a hallmark of the United States. And so many times people have said, as we've studied the United States, the thing that has jumped out is what we've been talking about here. This ecosystem that is in so many ways grounded in this basic research, the federal support, the financial health. It
Yes.
it's just impossible to imagine the United States being successful without it. But I also
Yes.
think sometimes it is easier to see something in someone else than to recognize it in the mirror. Maybe we in the United States don't often understand it well enough ourselves. What I think is fascinating about your personal story, your experience, is you bring two critical pieces together. A young girl in New Jersey who could never have afforded tuition if you had had to pay for it yourself, but could go because you got a scholarship that was made possible because of the financial health and other scholarship programs that are available. And then once there, could work, study more, and then pursue this passion and bring research to life yourself. As it turned out, you saw something that no one else was seeing at the time. In the middle of this AI winter, you saw a brighter future that would come out of all of this big data, all of these images, and you created something that became a big building block for all of the advances that we're seeing today. So personally, I want to thank you, not just for everything you've done, Fei-Fei, but for using your voice to help other people understand its importance. As we look to the rest of this decade and beyond, I think it's a lesson that we can't afford to forget. And you do us all a service by reminding us of it.
Well, thank you. That's very kind of you, Brad. As you said, I am, a story of this ecosystem, a story of a successful immigrant journey. But really, I owe this to every individual who has helped me. In my book, I talked about so many heroes. We just talked about my mom, but really, there are so many heroes, from high school math teacher to my graduate school colleagues, to my students, to mentors, and they're all here because there's an ecosystem that supports all of us. So I want to see this continue.
We all stand on the shoulders of each other. So thank you, Fei-Fei. You've been listening to Tools and Weapons with me, Brad Smith. If you enjoyed today's show, please follow us wherever you like to listen. Our executive producers are Carol Ann Brown and Aaron Tisi. This episode of Tools and Weapons was produced by Karina Hernandez and Jordan Rothlein. This podcast is edited and mixed by Jenny Cataldo, with production support by Sam Kirkpatrick at Run Studios. Original music by Angular Wave Research. Tools and Weapons is a production of Microsoft, made in partnership with Listen.